Today I'm going to talk about LeetCode problem number 347, top k frequent elements. Given an integer array nums and an integer k, return the k most frequent elements. You return the answer in any order. Okay, so basically we want to return, like if say k is 2, we want to return the top 2 most frequent elements, which in this case would be 1 because it appears 3 times, and 2, which appears 2 times. So the first thing that comes to mind for me is to use a heap. We can use a max heap, and a heap is basically, if we're talking about a max heap here, then basically the first element of the heap, if you call pop on it, the first element of the heap, it will always be the largest value. For a heap, it's not guaranteed that the rest will be sorted. So if you have like 3, 2, 1, the first value of heap will always be the largest of 3. We're talking about max heap here. And the others, they could be 2, they could be 1, they could be 1, or they could be 2, but this guy is always guaranteed here. And for a min heap, the opposite is 2. The first element, the one that's ready to be popped, is the smallest one. So what we could do in this case is count all the elements, how many elements there are. So for 1 there's 3, 2 there's 2, and for 3 there's 1. Store them all in the heap, and then pop from the heap k times. The runtime of this would be O of n times log n. N because we're iterating, because we're basically popping in or pushing into this heap n times and being in the length of nums. And to push this heap, it takes log n time actually. It's not linear. It takes log n time to push n elements to the heap. But this question says you must be better than O of n log n. One solution is do it O of n log k times actually, where k is the k most frequent elements. This would be better than O of n times log n because we're not pushing every element of this array to heap. Like worst case, if all the elements are distinct, like 1, 2, 3, 4, 5, then we're pushing n elements into the heap. Why not just push k elements into the heap at a time? So like first 3 here. Then it would be O of n log k. N because we're iterating through this array. We still have to go look at each element at least once. But we push the heap only k times. And push into takes a log k. We could do that. That's definitely better than O log n. So how are we going to still keep track of most frequent elements if we're only pushing k times? Well, what we could do is, first we could just push, have the dictionary here of the values, and they're corresponding how many there are of each value. And then since k is equal to, we push, I guess, the first 2 values we find in this dictionary into this heap here. So right now the heap would contain 3, 1 actually, and 2, 2. We're doing a min heap in this case. So we want a min heap because we want to compare this first value to all other subsequent values that are not in the heap. And if the number of those values are greater than the minimum value, then we push that in to the heap. So I'll attempt to explain this a little bit better. So let's say we have this array of 1, 2, 2, and 3, 3, 3, and k is equal to 2. So obviously what we want in return is 2 and 3. So in our heap here, which would be a min heap, so while min heap does not equals 2, we're just gonna push. So 1, 1, where this is the actual value, this is the number of times that value occurs. We get this from our dictionary. And 2, 2. Okay? So now that this has a maximum number of k values, what we want to do is still continue traversing the dictionary and look at what we have next is 3, 3. Since this 3 is bigger than this 1, since we have more 3's than 1's, what we're going to do is pop this guy and push this in. And because this is a min heap, the next smallest value is going to be in the front here, which happens to be 2, 2. And then we just pushed 3, 3. Okay? And since we're at the end of our dictionary, this is our final answer. It's 2 and it's 3. What if we had a 4 back here? Then we would, in our dictionary, we would have one value, where we would have a number of 4 values would be 1. So what we would do is compare 1 to 2. 1 is obviously less than 2, so we leave this main heap alone. What if we had 4 ones? Then, since 4 is greater than 2, because we have 4 of these 4's and 2 of these 2's, we pop this and push that here. So this is going to be n log k, because we're going to at most push into this heap k times at once. And pushing always takes log k time. And n, because worst case, if all these values are unique, we're going to look at all of them at least once. So this will be O of n log k. Okay, coding this up here. So first I want to initialize my dictionary that contains the value and the number of times that value occurs in nums. And I'll use Python shorthand here counter. Next I want to create my heap. And then I'll heapify that heap. Actually turn it into a heap instead of having it just be a regular array. Okay? And then for each key and value in the dictionary, if the length of the heap is less than k, then I'll just I'll just add to it. There's no point in comparing and replacing if we don't have k elements already. And just remember, this is going to be a min heap. Heap push into heap, and then val key, because we want to sort by the number of times the element occurs, so that the fewer number of elements in this min heap appears first. Else, if val is greater than heap, the first element of heap, the value here, then we actually want to pop that smaller value that we are peeking at. Heap, and then heap push, heap, and then it as a tuple, val key. Okay, so we're replacing this smaller number of occurrences with this larger number of occurrences. Or not replacing, actually, we're popping and then pushing this in, and then the first element from this heap now should be the next smallest number of occurrences. That's not necessarily this one. Okay, finally I'll have my result array, and for I in heap at this point should contain exactly k elements. Result.append I1, because in this tuple this value in the first position here, key, should be the actual element, and then return result. And I'll submit this. Yeah, list has no attribute. Heap queue. Okay, great. There actually is another way to do this problem with an even better runtime with a linear runtime of n, where n is the number of elements in nums, and that would be using a 2D array. So basically, worst case is all the nums are unique. So k equals 2 and all the nums are like 1, 2, 3, 4, 5, 6. Another case could actually be all the nums are the same. So if like k equals 1 and all the values are 1, 1, 1, 1, 1, 1, then obviously our output would be 1. So why not store the number of these elements in the 2D array, where the position of the array represents how many numbers there are of those elements. So for example, if you have this array here of length, I don't know, 6 with 0, 1, 2, 3, 4, 5. So here, this fifth element represents the elements, represents 5 elements in the nums array. And we would store this as an array. So this is where the 2D array comes in. So if we have 5 elements of value 1, so we would have 1 tier. If we also have element 2 and there's 5 of them, then we store 2 here, and etc. And then from this array, we work backwards, and our result array, we iterate through the elements, starting from the most frequent, and we know it's most frequent because they are stored at the later position of this array. So here, 1, 2. If k equals 2, let's say here for 2, we have for the element 4, there's 2 of them. But if we were looking for only k equals 2, then we look here. For the element 1, there's 5 of them. For element 2, there's 5 of them. So this is our result here. We still need a dictionary to keep track of how many elements there are in the array. But of course, we have O of n traversal. We have O n traversal for the dictionary, and then another O of n traversal to store these elements in this frequent elements array, and another O of n traversal to get the results. So it would be O of 3 of n. We'll remove the constant, so this would be O of n. To code the linear time solution here, I'm going to first have my frequency dictionary. Okay, and now the elements should be mapped to the number of times they occur. And then my frequency array, which is going to be a 2D array. I did a +1 here because arrays are 0 index, and it is just easier to take care of. Like if k is 1, I don't want to have to keep track of the 0. I don't want to have to remember that at the 0th position it represents 1 element. So I'm just going to do this and have it so that at the first position it represents an element with a frequency of 1. Okay. And now what I'm going to do is iterate through the dictionary. And as I iterate through this dictionary, so remember val here, the position in the frequency array represents the number of times that element occurs. So obviously val should be the index of the array. And that is an array there, because this is a 2D array. So I position val, it should be an array, and I can append the key to it where the key is the element, like 1, 2, or 3. And I'm going to have my result array here and iterate through the frequency array backwards because I want the most frequent elements. So I in range -1, and iterate backwards. An element array at that position should be the frequency array at that position I, and for each element in element array, I'm going to append the element to result. And how do we know when to stop? If length of the result equal to k, then return result. Okay, this ensures I stop once I have k elements in my result array. Just make sure, so if I have like all distinct elements and they're all lumped in at position 1 of the frequency array, I only get k of them. Okay, let's try compiling it. Let's see here. For blank in range. It's syntax. Oh. No, it's not that. Range. I'm not sure what the problem is here. Oh, yeah, missing a space. Okay, and I'll submit it. And there you have it. This is a linear time solution.